Alright guys, section 2.7 notes. We have finding inverses and dealing with inverses of functions. Part of these notes are a little bit of recap where we talk about finding an inverse algebraically. Hopefully you guys understand how to do that still from your time in Algebra 2. And then we'll talk about graphs of inverses, which might be a little bit new, what two inverses might look like on the same graph. We'll talk about maybe how to graph the inverse of a function, and we'll call it a day. So first of all, finding an inverse algebraically, there's really 4 steps. Okay, replace f of x with the variable y. We will switch x and y. We will solve for our new y, and then we will use our inverse notation. Okay? So some pretty simple steps, 4 steps. Basically, inverting a function really means switching the x's and the y's, switching the x values and the y values. Okay? So if our function, let's just give a very simple linear function. To find the inverse of the function, step 1, replace f of x with y. Step 2, switch our x and our y. Step 3, we're going to solve for y. We're going to add 5 to both sides. We're going to divide by 2. And the final step, we're going to use our proper notation. Also correct x plus 5 over 2. If you didn't want to split it up, I wrote it like this because that would give us a little bit more of an idea of how the graph would look. Another linear graph of slope 1/2, y-intercept of 5 over 2. Okay? All right. If we wanted to prove, okay, prove two functions are inverses of each other. And the second thing we kind of might do with inverses, we might ask you to prove that. Okay. The way that we prove that two functions are inverses algebraically, we do not follow these steps. Okay, this is a different type of thing with a different type of question. If f of g of x equals x and g of f of x equals x, then g of x and f of x are inverses. All right. So let's prove that these are inverses. Okay? The same two functions. We'll call f of x, we'll stay with f of x equaling 2x minus 5. And we'll say that g of x equals 1/2 x plus 5 over 2. And we're going to do both composite functions. We're going to do f of g and g of f. So f of g of x would be f of g of x. G of x is 1/2 x plus 5 over 2. Now I input this into the x in the f function. I get 2 times 1/2 x plus 5 over 2 minus 5. Let's continue on with our algebra here. We distribute. I get x plus 5 minus 5. Those cancel. I'm left with just x. So f of g of x equals x. We're off to a good start in terms of proving this. Now I'll do g of f of x. I rewrite it with the notation we talked about in the previous video. F of x is 2x minus 5. Now this notation means plug 2x minus 5 in anywhere we see an x in the g function. We distribute. 1/2 times 2 is 1, minus 5 over 2, plus 5 over 2. Those go away. We're left with just x. We have officially proved that those two functions are inverses of each other. That's the proof. If we asked you to prove two functions are inverses, you must complete both composite functions and simplify If they are x, if they both equal x, they are inverses. If one or both of them equal something else when simplified, they are not inverses. All right, let's go down to the graphs of inverses. Okay. So we talked about what functions look like algebraically when they're inverses, not only how to find it, but how to prove it. The graphs of inverse functions are symmetric to the line, or across the line, whichever one you want to think of, y equals x. Okay. Inverse functions are symmetric to the line y equals x. Okay. I'm going to give you a couple functions that we know to be inverses, the cube root of x and x cubed. And we'll see what these functions look like. Okay. This is the graph of x to the third. Okay. Different color here. Similar points, 8, 2. Sorry. And -2, -8, -2. And now, the line y equals x. All right. Just a visual representation of what inverse functions look like on the graph. Okay, if you saw these two functions on a graph and I asked you, are they inverses of each other? If I asked you to prove that, we need to kind of measure distance and symmetry. All right, but we're not going to. To the naked eye, it should look very much like these are inverses of each other. Okay, symmetric across the line y equals x. All right. So if inverse functions are symmetric to the line y equals x, then to graph an inverse of a function, we switch x and y values. So maybe we'll do the graph of the square root of x. 0, 0, 1, 1, 4, 2, 9, 1, 2, 3. There is the square root of x. If I asked you, regardless of whether you knew what this function was or not, I could create a function that looks anything, like anything I'd like it to. All right. If I ask you to graph the inverse of that function, we'd want to create a little table of values with the important points on this function. I've labeled 4 points, but maybe it's a graph that looks a little bit jagged, and you want to hit the points that are all the turning points, okay, the important points, to be able to get a clear picture of what the inverse might look like. Okay, so in the square root of x, we'll just make a little table down here, x f of x. We have 0, 0, 1, 1, 4, 2, and 9, 3. The inverse of f of x, then, would just flip those. So x inverse of f of x, we're just flipping them. 0, 0 doesn't change, 1, 1 doesn't change, but we'll flip these, switching the x's and the y's, 2, 4, again switching the x's and the y's, 3, 9. Let's put this on a graph and see if we feel good about it. 0, 0, 1, 1, 2, 4, 3, 9. Now, not needed, but just let's picture the line f of x. If we picture that line and we think about the symmetry between these two functions, this function and its inverse, then we should feel pretty good about what we did to graph its inverse.